Previously, we have discussed factoring polynomials using greatest common monomial factors. Now, I'm going to introduce to you another factoring technique, specifically factoring the difference of two squares. But what do you mean by squares, or specifically perfect squares? In your grade 7, you have already known that perfect squares, these are numbers or expressions that can be expressed to the power of 2. Okay, meaning to say a certain number can be expressed in a square of a number, or in short, to the power of 2. Okay, say for example, you have your 4. 4, this is, we all know that it's 2 times 2. So when you're going to express this into exponential form, or to the power of 2, this is 2 squared. Okay? Meaning 4 is a good example for perfect squares. Another perfect square is 9x squared. 9x squared is 3x times 3x. So express that to the power of 2. That is square of 3x. So we're done with the perfect squares. How about when we're going to get their difference? Difference of 9x squared and 4. What do you think is are the factors for this given polynomial? So before getting the factors for this polynomial, let me recall to you the special product. Okay, you have there the binomial, the sum of a and b, multiplied with the difference of a and b. That results, okay, and I'm going to solve this by FOIL method, by long method, whatsoever, getting the product for these two binomials. This results to a squared minus b squared. As you observed, a squared and b squared are both squares or perfect squares. And you have there the operation minus or difference, meaning you have your difference of two squares. So if we're going to reverse it, you have your a squared minus b squared. So meaning the factors for this binomial are a plus b and a minus b. So we're going to use this technique or this tip. So how? Okay, you're just going to get the square root of a squared. That is a. Okay, you write a in the first term of every binomial. And then you get the square root of b squared. So the square root of b squared is b. Okay, so you write them, the b's, for the second term for every binomial. So you have your plus and then the other is minus. That is how to factor. Okay, now go back to 9x squared minus 4. What do you think are the factors for 9x minus 4? Okay, so very easy. You express each term first to the square of a term or square of a number, or to the power of 2. So 9x squared is square of 3x minus 4 is the square of 2. And then you factor. So here, it's very clear. The base here, the base is the expression or the term below the exponent. So you have your 3x. So what I said a while ago is you have a square root. So actually, when you're going to take the square root of 9x squared, that is 3x. So you have there, you write 3x for the first term. Okay? First term yan. First term for every binomial. And then, you have your 2 squared. So you get the base. So that is minus plus 2 and then minus 2. That's it. You can also have your minus 2 or plus 2. You have the same answer. Okay, what I told you last time, you can check actually the factors if they're correct. How? We're just going to multiply the factors. Okay, let's do it. Let's check if the answer is really correct. Okay. So when you multiply 3x plus 2 and 3x minus 2. So you have 3x times 3x, that is 9x squared. 3x times negative 2, that is negative 6x. 2 times 3x, that's 6x. And then, lastly, 2 times negative 2, that is negative 4. Simplify. So you have your 9x squared. Negative 6x plus 6x, that is 0. So, remaining minus 4. Okay, you got the original given, or I mean the given polynomial, which is 9x squared minus 4. Okay, now I'm going to give you several examples on how to factor difference of two squares. So, let's have your number 1. You're given here x squared minus 9. Okay? So first, you express each term to the power of 2. So you have your x squared minus 9. X squared is just, yes, that's the base x, then that is squared. And then you have their 9. 9 is just 3 squared. Okay. The square root of 9 is 3, or 3 squared. And then, you get their bases. Okay, I just want to clarify, ha. Recall. A to the power of m. So, A is the base, and m is the exponent. Please bear that on your mind. Okay. So get the base for the first, or I mean the square root of this x squared. It's just the x, or the base for this first term. So you have your x. So put it here, first term. And then 9. You have your square of 3. The base for that is definitely 3. So plus 3 minus 3. Or just get the square root or the base for the perfect square form. Okay? So the answer or the factor for the polynomial x squared minus 9 are the sum of x plus 3 multiplied by the difference of x minus 3. Okay, let's have another example. A to the power of 6 minus 21, 25b squared. Okay, let's answer directly. Okay, express each term to the power of 2. So, 16a to the power of 6, that is 4a, or getting the square root of 16a to the power of 6, that is 4a cubed, quantity squared. Actually, when you're going to get the square of 4a cubed, square of 4 is 16. Square of a cubed is a to the power of 6. Just multiply 3 and 2. And then minus 25b squared. Okay, express this to the power of 2. That is the square of 5b. Okay, very easy. So, get this base. 4a cubed. Another one, 4a cubed. And then, plus 5b minus 5b. That's it. Again, you can check your answers by getting the product of the factors. You will get the given polynomial. Okay, let's proceed to example number 3. Okay, the same method. Express each term to the power of 2. So, a squared, that is a. B to the power of 4 is b squared. And quantity squared. Okay? And then 81, that's just 9 squared. Okay, factor. That is a plus b times the quantity of a minus b. So, get the base. ab squared plus here that's 9 and the other one minus 9. That's easy. Okay, proceed to number 4. You have there x to the power of 4 minus 81. Okay, x to the power of 4, that is the square of x squared. So express each term to the power of 2. And then 81, still, that is minus 9 squared. Okay, so you have here, okay, get the factors. Base, you have their x squared. Okay, first term here, x squared also. And then you get the 9 plus 9 minus 9. Okay, but notice, this x squared minus 9 is still factorable. Okay, this is also difference of two squares. Okay, again class, not all polynomials can be factored using the difference of two squares. Just remember, if there are two terms and you have their binomial and the operation is minus or subtraction, it might be difference of two squares, given the two terms are both perfect squares. So here, x squared and 9 are both perfect square. So it can be still factored. Okay? So we need to factor this. Okay, so that becomes, just copy this, x squared plus 9. So since this is difference of 2 squared, x squared minus 9. So expected, you have two binomial factors. Okay. So x squared. Okay. Note. For x squared minus 9. Express each term to the power of 2. So you have there x squared. 9 is 3 squared. So that would be, get the base, x, the second binomial x, then 3, the base for second term to the power of 2, plus 3 minus 3. So you have here x plus 3 and x minus 3. So, as you observe, there are 3 binomial factors for x to the power of 4 minus 81. Okay? So, you must be careful if that certain binomial or a certain polynomial is still factorable. Okay, let's have a last example for difference of 2 squares, factoring. Okay, so we're going to observe the 2 terms. So you have your 3w squared and 48. 3 is not a perfect square, as well as 48. So what do you think we're going to do? We cannot apply here difference of 2 squares. So go back to our last topic, GCMF, greatest common factor. So you look for their GCMF if there is GCMF. Okay, so you have your 3w squared minus 48. Look for their GCMF. Yes, there is. 3 and 48. Their GCMF is 3. Okay, what to do with that? Okay, so you divide each term by the GCMF, which is 3, minus 48 divided by 3. Okay, so you have 3 multiplied by 3w squared divided by 3, that is w squared, minus 48 divided by 3, that is, okay, that is 16. Okay, notice this w squared minus 16 is difference of 2 squares, or is in the form difference of 2 squares. So we can now apply the technique. Okay, let's do it. So express each term to the power of 2. So w squared minus 16 is 4 squared. Okay, so you have here, this has 2 binomial factors. So binomial. Okay, get the base. So w, and the base for this 4. So plus 4 minus 4. That's the pattern. So meaning the factors of 3w squared minus 48 are 3, the sum of w plus 4, and the difference of w minus 4. Okay, that's it for factoring the difference of 2 squares. Always remember to check if there are or there is GCMF. Okay, first step. Look for their GCMF, greatest common monomial factor. And then apply the technique for difference of 2 squares. Okay? That's it. Okay. Okay, thank you for watching. I hope you understand. Feel free to comment on the videos, or what are your questions, what are your clarifications. Thank you. God bless.